Okay, welcome everyone. Thanks for coming. This is the week 6 webinar of the online statistics class. So this week 6 is halfway, by the way, because it's a 12-week class. So we're at the end of this week. We are at the end of the first halfway point. So I just want to mention a couple things before I go over the schedule. I did receive your projects. And I want to let you know that it takes me a while to read through those and grade them. It's over 300 pages of projects to read, so it's not the kind of thing I can do in 5 minutes. And I decided to do your discussion post assignments first. I did that. That was today's thing. And I taught, of course, too. But tomorrow I'll start working on grading the projects. That's my plan. And it'll take me some days because it's hundreds of pages. It's not something I can just do in a short amount of time. So, be patient and I will grade the projects, but I definitely, if those who submitted them, I definitely saw them, but I just haven't had the chance yet. And tomorrow morning I'll start grading and then grade some more Wednesday, grade some more Thursday. Maybe I'll finish Thursday, maybe Friday, Saturday, we'll see. So let you know the projects do take some time to grade. But I'm not a procrastinator. It just does take me time to do the grading. So let you know, in terms of the plan today, I'll answer any questions that you have as always, and that could be any time throughout the webinar. And today is actually day 1 of not just getting tools. Today we're from now until the end of the entire course, we are going to be using statistics. So it's really easy for me to just go online and find something that's going on today and use statistics with it. Find where they used it or use it on what they've got. So that's the good news, and you'll be able to do that too. So using is easy. And the focus for this week is confidence intervals, which we'll talk about. And we'll have 2 different types. We'll have a confidence interval for means. Okay, and kind of the idea is that you do a sample and you get your sample mean, but how much error do you have? And we talked about the standard deviation giving the idea, but that may not be good enough. So we'll talk about how you can get more refined. So then we'll get into this confidence interval for proportions. Okay, because means, remember, have you ask a survey question and someone gives you a number, okay, and the data you put is numbers and a bunch of numbers in their spreadsheet. For proportions, it's a yes/no survey question. Okay, then we're going to do something that's actually really important you may not even thought about, and that is how big a sample size do you need to have data that you're comfortable with. Okay, we've already seen that for means, you need more than 30 to be able to use the normal distribution. But the question is, you might have 35 or something, but then you might be off by a lot and it's useless. Okay, you could use the normal distribution, but you don't have any good information. So that could happen. So we'll talk about how do you come up with how big a sample size you need to get good enough information. And then we'll do the same thing with proportions, with the yes/no kind of question. And that is the plan today. I want to remind you that this is week 6. What's important about the number 6? Hopefully by now you all know. Yeah. 6 is an even number, so there's an exam this week. So make sure you put in the time and get tutoring help if you need it for anything you don't understand, kind of math stars, whatever it is. And but it is week 6, so there is an exam. And just a reminder, the exam always covers everything, but is more focused on the stuff that you've had since the last exam. So if you think about the stuff since the last exam, that will be chapter 7 and chapter 8. So I think something like half of the exam is on chapter 7 and 8, and the other half is on chapters 1, 2, 3, 4, 5, and 6. So you can see it's definitely more focused. So now you're going to really now notice as time goes on that focus piece. And as always, the last couple questions will be will be, written questions. You type out your stuff instead of just a number. And those are sentences, paragraphs, whatever. And I grade that. And just a note, a heads up, the computer automatically gives you a 0 until I grade it. And then I grade it and I give you points. So don't get too scared when you have a low score, because it could go up a little bit. It won't go up a huge amount, but it can go up some. So that's just a note in terms of this week. So let me ask you, are there any questions about anything? Any questions? I'm always happy to answer questions. Okay, if there aren't any questions, I want to remind you, you can ask questions throughout the time. Feel comfortable whenever you need to ask a question. So I have a question for you, and I'm going to require you to put in the chat box your answer. It has to be in the chat box. But here's the deal, and this is true of anything I ever ask you when we do these Zoom lectures, is that if you don't feel comfortable, you don't have to tell the truth, but you have to make it reasonable. Sound good? Sound fair? But my guess is most of you will be able to tell the truth. And if you don't, that's fine. But make it reasonable. This is something I've been asking, by the way, for my entire 28 years of teaching statistics. So I've actually seen the answers to this, and it's a fun little question. And it turns out to be a really important societal question for lots and lots of reasons, even though it just looks fun. And it is, how old were you when you experienced your first passionate kiss? And by the way, if you have never had a passionate kiss, just give me your age. Hopefully, maybe you'll get a kiss this year. Okay. But if you have, and by the way, getting a kiss on the cheek from your mother is not a passionate kiss, by the way. This is boyfriend, girlfriend type thing, big dates. So put it in your chat box, and I'm going to type in the numbers that you put in. And I see 16, 11, 15, 15. Let me type it out. And 18. Okay, so what we might be interested in is what is the average age of first passionate kiss for college students, right? You're all by definition college students. First thing, do we have a large enough sample size? This should be obvious. Yeah, definitely not. Definitely not. This is one of those cases where I have no other choice. I only have so many people in the group today. So, this is what we've got. So don't trust it completely, but we'll talk about that. So the sample size is too large. One thing, this is a quantitative survey question. And with a quantitative survey question, that tells us that you need over 30 to use a normal distribution, or you have to start with the normal distribution. So I'm going to have to assume we have a normal distribution. And I have no clue whether age of first passionate kiss is normal or not. So we're just going to assume. Remember, assume starts with the 3 letters that you all know. So it's make an ass out of you and me as assume, right? So we're just going to do it. Sound good? All right, what I'm going to do now is I'm going to find the sample statistics that I care about. So I'm going to go in here and I'm going to go statistics, one variable statistics calculator, and put those numbers in. And I could look at as a sample, the mean was 15. It's a nice, easy number. So X bar is 15. The standard deviation I got, not as easy, 2.5495. And that one I don't need a calculator for. That's 5, because that's how many people answered. Any questions so far? That's supposed to be easy stuff, chapter 2. Okay, SE. Remember what SE stands for? Any guess? It's what I use when I want to type in Greek and stuff. I guess. SE stands for? Let's see, y'all jumping in. Close, close. Standard error. Standard error. So standard error. I know it sounds like sample error, but it's standard error. And then there was a formula for the standard error. Do you remember the formula for the standard error? And by the way, our best guess is going to be that sigma is 2.5495. So we're going to use that as our best guess. There was a formula. You take the standard deviation, it's not just the standard deviation, and you divide by the square root of n. So I'm going to take the standard deviation. Let's do it in the calculator. I can take the standard deviation. And then I'm going to divide by the square root of n was 5. Any questions on coming up with a standard error? About 1.14? Okay. So now what we're going to do is we're going to assume we have a normal distribution. It's a big assumption, and we're going to draw a picture. So here's the picture of the normal distribution. Okay, X bar is going to be our assumed mean for this normal distribution. That'll be 15 in our case. And what we want to do is we want to say, well, how far out from X bar do I have to go so that I'm 95% confident that the population mean is in between those numbers? So that's the idea, and that's what the whole idea of today is you start out at the mean, or later it'll be proportion, and you say, how far out should I have to go so I'm covering 95% of the area? Because I want the probability of being between those two numbers, left and right, to be 95%. Any questions on that idea? Okay, we're going to call this the 95% confidence interval. And I'm going to mention something, and I might mention again too. One of the things we don't know is sigma. Do you agree? We don't know the population standard deviation. We only know the sample standard deviation. So this SE that I created, this 1.14, there's a little bit of error in that because it's just a guess. It turns out that you actually adjust this curve to deal with that extra error. That adjustment of the curve takes that normal distribution and it turns it into a different distribution, which is called a t distribution. Okay, and everyone calls it t distribution. It was originally called the student's t distribution because it was named after the professor's students. He wanted to call it the students after my students, is what he said. And the funny thing is, you'll never guess why, but this has everything to do with beer. And my guess is you have no idea why it has everything to do with beer. Okay, turned out the guy who figured this out worked in a beer company, and he was actually using statistics to look at all kinds of data on beer and finding out that it wasn't working 95% of the time. It was off a bit, and he came out with his new math to be able to handle this extra little error. So this is a funny little story, but it's the history of what's going on here. Okay, so we're going to be using that. So we can find the 95% confidence interval now. And now, instead of having to use all these numbers and doing all the work, and I'm going to say this a lot in this class, you're not going to have to do all the messy number calculation. Any guess on what we're going to do instead? Yeah, I made a special calculator for this. Okay, so I'm going to go back to the calculator menu, but I wanted to show you the picture and what's going on so you get the idea of how this is happening. even though the calculator is going to do it behind the scenes for you. But it's important to understand that this really comes from this bell-looking curve, and then looking at the interval and saying, when is that, for what values of lower bound and upper bound is the area between going to be 95%. So what I did is I created a calculator, and I called it the confidence interval for a mean. In this case, we have data. And I'm going to put in the data, which was 16, 11, 15, 15, 18. And the confidence level, we're going to use a 95% confidence level, because that's what I'm interested in. And that's 0.95. And just a note, by the way, 95% is the standard amount for social science. And age of first kiss is very much social science. Hopefully you all agree with that. So 95% is what you would use. You use a higher percent maybe in medicine. Any guess on why you would want to be more confident when it comes to dealing with like new medicine? Yeah, because if you get it wrong, you might kill someone. Okay, and that's not good. You might want to be 99.99% confident that you're not going to kill anyone. Does that make sense? If you're a doctor or a medical researcher or something like that. So there are times when you don't want to use 95%. But if it's just like age of first kiss, you're not going to kill anyone by publishing that, right? Okay, at least I hope not. Okay. So I'm going to use 95%, and I'm going to hit calculate. And what it gave me back the X bar and S that we already saw, because I figured I might as well have that when I programmed this. There's enough space. And it also gives you the lower bound and the upper bound. So I'm just going to go to 1 decimal place, because honestly, nobody really cares about 2 decimal places of accuracy for the average age of first kiss. Okay. I know for your first kiss, you cared about the day you got kissed because it was wonderful, possibly, right? Hopefully it was wonderful. But in terms of the average age of all, college students, 1 decimal place is just fine. So I'm going to go 11.8 to 18.2. Any questions on this confidence interval so far? Haven't interpreted it yet, but you can kind of see. So that means right here, this left side is 11.8, and this right side is 18.2. And the area in between the left and the right under the curve is going to be 95% or 0.95. And hopefully from the last couple of chapters, you understand how this all happens, even though it all happened, behind the scenes in the calculator. But it's important that you understand what's going on. Any questions so far on this? Okay. So I already talked about the fact that it's not a normal distribution, it's actually a t-distribution. So I'm going to skip that. So we can interpret this confidence interval. And here's how it works. With 95% confidence, the population mean age of first kiss is, for college students, is between 11.8 and 18.2. Years old. Any questions on this interpretation? Any questions? It's very important, the wording. I want to let you know, this first word, with, that will always be your first word. You must put that down when I say interpret the confidence interval. Got it? Okay, I will take out points if you don't have the word with to start. I want that there. Got it? Everyone okay with that? Okay. And I also want to give you a little heads up. It's a little too early to talk about more details, but any guess on one of the main things you're going to have to do with project 2? Any guess on what you're going to have to do with project 2? One of the things? Confidence intervals, exactly. You're going to have to find a confidence interval. We're not quite ready for what you're finding it of, because that's actually chapter 10. These are easier examples. We'll have a little more sophisticated examples later, but you're going to have to find confidence interval. Okay. I will let you know that, the sample mean that you got was 15 years old. So when I started this, and in fact, even when I was a kid, do you think it was older or younger or the same? I'm seeing both. It was definitely younger. Definitely younger. I'll tell you, I don't know how old y'all are, but when I was a kid, we had a lot more fun. I was my first age was 13, and I was a nerdy math geek, and everyone laughed at me because I was so old before I had my first kiss. Okay, because 13 was really old in those days. Things are different now, but just let you know, and it's actually important because now that you're older when you have your first kiss, you typically also older when you have, what's the next stage after your first kiss, the next big stage? You can't talk about with little kids. Anyone know? Sex. Okay, that would be the next big stage. It would be sex after first kiss, right? And the next stage after that is having a baby. And it turns out in America, we're much older when we have babies, and our birth rate has gone way down. We're actually below, in terms of our birth rate, we're actually below sustainability, and that's one reason why we have to have immigration, because otherwise we would go down in population. So those are all statistics, and it's a lot about confidence intervals in terms of what you're looking at. So just let you know, this stuff is important. Okay, there's deep, deep, deep reasoning for this. Okay, what does the confidence level on top there mean? Yeah, so guess what? Just in a minute, I'm going to answer that question. So, my next question is, and I didn't type this while you were talking, it was already planned. What does it mean to be 95% confident? So interpret the confidence level. So now we're going to do that. So you asked the perfect question because that's what it's about to do. And this one is a lot more complicated. So you want to, get this down. Okay, so now what you want to think about is being in the business of creating confidence intervals. Okay, so maybe you are a professional researcher, or maybe you are, in charge of, a big news company, or maybe you're in charge of Gallup poll or something like that. So if you're in that business, you're going to be doing lots and lots of confidence intervals. And if we think about our confidence interval that we got, this 11.8 to 18.2, it may or may not be successful. And I consider it being successful if the population mean age of first kiss really does lie in this. And I consider it a failure if it doesn't. If the population mean age of first kiss was, say, 20 years old, well, then we mislead people. Do you see that? On the other hand, if it was, say, 16 years old, then we haven't misled anyone because it's in this interval. Do you see that? So if you are in the industry of doing statistics and creating confidence intervals, then if you have a 95% confidence interval, that means 95% of the ones that you do are going to be successful and contain that population mean. And then 5% are going to be unsuccessful, and they're not going to contain the population mean, either going to be too low or too high. So now I can take that idea and I can write that out. So if many, okay, and we've seen that word many before when we talked about, remember what did we talk about when we saw the word many? See if you can remember. And then I'll tell you if you don't remember it. Probability, but a specific type of probability, something with probability. If it helps, it was in chapter 4, not chapter 3. Remember? These were just to create, that was part of it, but what was it? It was the expected value. Do you remember that? So it's the same idea as the expected value is thinking about if you do it a lot of times, what's going to happen? Same thing. If you compute the confidence interval many, many times, so if many samples of size 5 in this case, because that was our sample size, are created to find the confidence interval for the average, for the population mean age of first kiss. Then each sample will result, or produce is probably better, its own confidence interval. 95% of these confidence intervals will include or contain the population mean age of first kiss. So this is all in theory. You kind of imagine doing it over and over and over and over again. And each time you're going to get a different confidence interval. 95% of those confidence intervals will contain the population mean age of first kiss. And by the way, 5% won't. Any questions at all on interpreting the confidence level? That's what that 95% means. Okay, so if you're a researcher, that means 95% what you publish in your paper is actually going to be true. And 5% of the time, well, you screwed up. Doesn't mean you did something wrong. You just got bad luck. You see that? Because it's all about luck. Because we are assuming that we don't have a bias sample. If you have a bias sample, you can't do anything in statistics. Does that make sense? Any questions at all? Any questions at all on this? Because that's usually the hardest part. Always pay attention in the question. Are you being asked to interpret the confidence interval or the confidence level? Confidence interval has that first word with. The confidence level has the first word if. Okay? And in fact, always if many samples of size. Any questions at all on this big thing? No questions? Okay, if not, we can move on. And by the way, just if it helps, I did some, I wrote a template. So with however much confidence, it can be concluded the population mean, whatever you want to talk about, is between whatever the low number is and whatever the high number is. So that will help you in interpreting, having this template. So you just fill in the X's. Okay, but please do not put a bunch of X's in your interpretation. Make sure you change the X's to what it's about. Okay, and for the level, if many samples of blank, 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 okay, are taken, then each would produce its own confidence interval, whatever percent it is, 95 was what we did, of these confidence intervals will contain the true population mean, whatever, that could, in our case, it was age of first kiss, and however other percent won't contain the true population mean. Any questions? Any questions on the confidence interval for a population mean? Okay. And again, you have to understand all the old stuff, like how to create an unbiased study, understand the normal distribution, understand the mean and the standard deviation, central limit theorem, all that stuff made this happen. Okay. And just a note, if you don't have a sample size over 30, then you got a big assumption to make, which is almost always wrong. So you really shouldn't do anything you really care about with a sample size under 30 or 30 or under. Okay, like ours was just to show you how this works. I would never publish this age of first kiss after a sample size of 5. That would just be wrong. Does that make sense? So I want to give you that big heads up. And again, in your project 1, you had to have a sample size over 30. That was a reason, because you better have that when you have quantitative data. And by the way, the same is going to be true for project 2. You're going to have over 30. Okay. And it'll be over 30 of each. I'll get into what each means later. All right. So we just did means. So the next thing to worry about is proportions. Okay. And one of the things I love about teaching statistics is I can just before class, I can go online, and in minutes, I can find an example. So I figured I'd do an example with proportions that was relevant. And my guess, unless you've been, putting your head in the sand, you probably all know what the big bad news is the last couple weeks. What's the big bad news? You may have other bad news, but the main big bad news that's been in the news, like the headline of everything news the last couple weeks is, Israel Hamas. So I figured I'd give you one of those. Okay. So I went online and I looked up a study that was done recently. And this is Quinnipiac University poll is who did the study. And so the question is, what percent, this is what they asked. They didn't ask, but this is what they want to know about. What percent of Americans are concerned that the Israel-Hamas war will escalate into a wider war in the Middle East? Okay, because we don't want this to be the next World War. We don't want this to be World War III. Okay, and by the way, I hope none of you want this to be World War III. That would be just bad. So how worried are Americans? Does that make sense? So what we might want is a confidence interval, maybe a 95% confidence interval. Okay, on what percentage of Americans are concerned? Because you can do a survey, but that's not going to tell you everyone, right? How many Americans are there, by the way? Do you know? You know how many people are in America? Yeah, over 300 million. Okay. And if you do adults, it's like something like 200 and something million, something high million. There's no way in the world that you could ask everyone. This is not possible. Okay. There isn't time. By the time you asked everyone, it would be 100 years later. No one cares about it anymore because it's like old news. So that's why you do surveys. Is that clear? You cannot get the population proportion. You cannot get the exact population proportion. Okay. So it turns out what they did is they surveyed 1,737 adult Americans. And by the way, adults, and hopefully you know because of Project One, why they surveyed adults. It's not just me telling you, this is what people do. Why do you only survey adults? And I mentioned this for Project One, it's the same reason. It's not that you can't, but there's all kinds of legal problems. Yeah, legal issues. Okay. You don't know how hard it is to do surveys of children. Doesn't mean it never happens, but it is such a pain. So it's much easier to survey adults, and that's who they surveyed. Okay. Now they had, do you remember what P with that little hat on top represents? What does that mean? right? N was a number of people that were surveyed. That's why I use the letter N. Do you remember what a P with a hat on top means? That was an important one that happened last week. You remember? Yeah, that's a sample proportion. Okay. So the sample proportion of the surveyed Americans who are concerned that the Israel-Hamas war will escalate into a wider war in the Middle East is 0.85. Okay. It'll make it easier to read 0.85, same thing. Okay. You can also say 85% of those sampled are concerned that the Israel-Hamas war will escalate into a wider war in the Middle East. Do you see that? Just a note, and we're going to need this. Given that information, how do you decide on how many people said yes to the survey question? Yeah, we multiply N by P hat. So 1737 times 0.85. I'll just pop it in here. I typed it wrong. 37. It's 1476.45. How do I know it wasn't exactly 1476.45 people that said yes? I know for sure that's not what happened. Yeah, you can't have 0.545 person said yes. Okay, so we should round to the nearest whole number. I'm going to say 1476. So number of yes is 1476. And the number of no, by the way, that we can just subtract 1737 minus 1476. And I get 261. Any questions? Any questions on coming up with the number of yeses and the number of nos? All right. So here's a question I have for you. Did they survey enough people so that we can use the normal distribution? Yeah. Yeah, how do we know? Yeah, so don't say 30. Remember, you promised you wouldn't. So good. It's at least, and not at least 5, it's actually more than 5. More than 5 yes, and more than 5 no. So 5 isn't enough, 6 is enough. Does that make sense? Just like more than 30 means 31 for your minimum. Okay, so 1476 is definitely bigger than 5. And 261 is definitely bigger than 5. Okay, that should be obvious, right? You don't need a calculator to know those are bigger than 5. All right, so what that means is we can use the normal distribution. If you don't have the bigger than 5, basically you say your sample size is too small, I have useless information. Is that clear? You're not going to find a confidence interval if you don't have both bigger than 5 with proportions. There's no assumptions you can make, it's just bad. Okay. In advanced statistics, you can do a little more, but I'm not even going to go there. Sound good? All right, so now we want the confidence interval. So here's the thing. Don't use this calculator. This won't work. Why won't this work? Yeah, we don't have numbers. We have a bunch of yeses and nos. Okay, we're not going to be able to put in a data with commas separated. So what I need to do is go back to the calculator menu. And now, which calculator should I use? Yeah, confidence interval for proportion. And I want to note something. And that is, we are actually changing now. Before, we were kind of doing like 1, maybe 2 calculators a week. There's a lot now. This week is going to have 5 different calculators that you can work with. So one of the most important things for you to get down is which calculator, because there's a lot of choices. Okay, and we're going to go through all these today, but there are a lot of different choices. Does that make sense? Okay. Had I not done it with a lot of choices, the calculator can get really complex and it's really hard to figure out how to use the calculator. So instead, I wrote it this way. And most people like that. So I'm going to do confidence interval for proportion. And it says fill in the sample size n, the number of successes, x, and the confidence level. So notice over here, I found the number of yes answers. Okay, you need that for this calculator. Having the proportion isn't enough. You need to do NP hat. So our N was 1737. Our X was 1476. Confidence level. Now, this is, again, kind of social science. So what do you think a good confidence level would be? Yeah, 95%. I want to give you some kind of my own experience. I've done some consulting work. I like doing consulting work because then I actually learn what people are actually doing or need with statistics. And I actually did it for the Forest Service. And they wanted a 90% confidence interval, not 95. And the reason is if you have a 90% confidence interval, so now I'm going to show you the picture again. Having a 90%, that means you're going to have a smaller probability. But if you have a smaller probability, then you're going to have a narrower margin of error. Do you see that? So if you have too high a confidence level, then you're going to have data that's not very meaningful. So for example, I can be 99.999% confident that the age of first kiss is between 0 years old and 150 years old. But how much meaning does that have? Have you learned anything if I told you the age of first kiss is between 0 years old and 150 years old? Have you learned anything? Yeah, I haven't told you anything. It's totally useless. Do you see that? So it's really a give and take. So if you want to make that confidence interval, if you want to make the confidence level to be like 99% or really high, you have to have a wider margin of error, which means you have less meaningful interval. Do you see that? On the other hand, if you're willing to have a 90% confidence level, then you get a narrower margin of error. Okay. And the margin of error, by the way, by definition, is a distance from X bar to the edge of the confidence interval, or P hat to the edge of the confidence interval, depending on what you're doing it with. Does that make sense? And that's called the margin of error. Okay. And in our class, we use capital E for margin of error. So if we want to find the margin of error here, by the way, if you add these two numbers, you get 11, you get 15. So the margin of error is how far from 15 these numbers are, which would be 3.2. 18.2 minus 15 is 3.2. So the margin of error for our confidence interval is 3.2, plus or minus they often use. Does that make sense? Which actually is pretty high. What is if you want to keep it at 95%, but you want a smaller margin of error, what do you have to do? The hint is it's more work, but not impossible. Yeah, larger sample size. We had a sample size of 5. That's why we had a huge margin of error. If you did a sample size of 100, you would have a much smaller margin of error. Do you see that? So now we're ready for, let's do a 95%. and calculate. And notice the margin of error is not that big because we have a very big sample size. You could say 0.8, let's go maybe, how about four decimals? So 0.8665. Comma, 0.88497. So the margin of error is not that big. Do you see that? Remember, 85% was our p hat. So it's like 1.65% is the margin of error here. Ish. Okay. We had to do some rounding, so it's not perfect. If you want to find the perfect margin of error, you add these up and divide by 2. And it's like a little more than 1% margin of error, which isn't so bad. You know, if you're off by only 1% or so, you got pretty good data. Do you agree? And that's because their sample size is big. All right, so now let's interpret it. What's the first word that I should write down to interpret the confidence interval? Whether it's means or proportions, by the way. Yeah, with 95% confidence. And what we can do, if you're going to do it to like the general public, it's nicer to use percents between 86.65% and 84.97% of all. And that's how you make sure that you're talking about the population, Americans, and maybe American adults. And then I'm going to make life easy. I'm going to copy and paste the question. Are concerned that the Israel-Hamas war will escalate into a wider war in the Middle East. I'll make it prettier. This is a Google thing. There we go. Any questions? Any questions? Okay, notice it's a pretty high percent. Okay, that means that definitely most Americans think this way. Okay, vast majority. Not everyone, but the vast majority are concerned. Okay, and by the way, I do not want World War III, and hopefully you don't want it either. Any questions at all on this example to interpret the confidence interval? Okay, we can interpret the confidence level. I want to look at time, and I think we have enough time. Okay, so the question is, what if you have yes, no, and don't know? More than just 2. So I got bad news and good news. The bad news is you don't know how to do this. You won't know this week. But the good news is you will know by the end of the course. So you need to have patience, and that'll be chapter 11. Okay. And it turns out it won't be confidence interval. We're going to be doing other stuff, but we're going to be working with those kind of things. Yeah. So you can do chapter 11. And in fact, you could just, you know, yes, no, don't know. You could look at the proportion who said yes versus the proportion who didn't say yes and turn into a yes, no question. You could do that. And in fact, I know it's going to sound weird, but I did that. I did that. When I went to the original article, it actually did not, it wasn't completely yes, no. It did kind of like what you said. It wasn't don't know, but it was very concerned, not too concerned, or not at all concerned. But I turned it into, and actually they did it too, into the concerned versus not concerned. Okay, so that's one way of doing it. And the other way is something called chi-square test, but we're not going there today. We do that later in the quarter. It's the second to last week of new material. So it's actually week 10, I believe. Oh no, third to last. So it's week 9. So we still got 3 more weeks. Okay, but good question. Good question. All right, we could also interpret the confidence level. Let's make it bigger. Okay, and basically we have a template. We could do the same thing, and we could say if many samples of what was it, 1,737 adult Americans or American adults were surveyed, then each sample would produce its own confidence interval. For the population proportion, of American adults who are concerned that the Israel-Hamas war will escalate into a wider war in the Middle East. 95% of these confidence intervals will contain the true population proportion of American adults who are concerned that the Israel-Hamas war will escalate into a wider war in the Middle East, and 5% more. Any questions on interpreting the confidence level? Any questions? Okay, so the next thing I want to talk about, the next thing on the agenda is sample sizes. And remember the central limit theorem for means, it said that sigma sub x bar is equal to sigma over root n. Okay, do you remember that? That was a very big theorem, very important. All right, if we go to the picture again, this picture is important. Then if you want to see how far it is from here to here, what you can do is you can take the standard deviation sub x bar of the standard deviation of the sampling distribution and multiply it by not 95%, but by the z that comes from that in the normal distribution. Okay. So now I can go back and we can say this margin of error is z times sigma sub x bar. And in particular, that's equal to z sigma over root n, because that's the formula. And then you can solve for n, and n is equal to z sigma over e quantity squared. And that's how you find how big a sample you need if you want a certain confidence level and a certain margin of error, and you know the standard deviation. Okay, typically, you don't know the population standard deviation. And when you don't, you can guess at it. And sometimes you guess at it by doing a small sample and using the standard deviation of that small sample and just saying that's as good as I can get. Does that make sense? There are some other ways you can do it too, but that's one of the main ways. Sometimes you do the preliminary estimate. All right, so let's do an example. And here's the example. Suppose you wanted to find a 95% confidence interval for the population mean hourly wages of nurses in California. Okay. And if you're interested in being a nurse, I usually get a few that's why they're taking this class. On those, some yeses, I don't know. Aha, got one. I always get at least one. Almost. It's been a long time since I didn't have at least one person wants to be a nurse. So, you might care about how much money you're going to make, right? Okay. You don't know what the wages are in California. Okay. And hopefully they've gone up a bit with inflation. Okay. Let's assume the standard deviation is $25 an hour. Okay. Okay. Suppose you did some little preliminary study and that's what you found. If you want a margin of error of no more than 50 cents, okay, you may not care about an extra 50 cents an hour or 50 cents less an hour for what you're going to make, but you might care about $5 an hour. Does that sound right? Those who want to be nurses. Okay, well, how many nurses must you survey? Do you see how that thing is? For your project, you surveyed, a little over 30 because I told you had to. In the real world, there's nobody telling you what you have to do. But if your sample size is too small, you end up with a really big margin of error and you have useless data. What's the problem with the sample size being too big? There was a problem, a big problem. Here's the thing. What if I told you for your project, you had to survey 1,000 people? What's the problem with that? Yeah, it takes a long time. It's a huge amount of work. Or if you're paying people to do it, it's a lot of money just to find out. So you don't want to overdo it because that's just way too much effort and often way too much money to do it. But you don't want to underdo it because then you have useless data. So what you want is like just the right amount. Does that make sense? And this is an example of saying, well, how do you find out what just the right amount is before you do your survey? After you do your survey, it's too late. See how that works? All right, so now I'm going to give you the good news and the bad news, which isn't bad news for you. The good news is I created a calculator for this. The bad news is there were other instructors, not at my college, but other colleges that got mad at me. You know why? You may not have any idea. Yeah, I made it too easy. And they said, now my students are just going to like do this and not have to use the formulas. But students never complained. But I did have a few people that didn't like it because it was too easy. Okay. So what you do have to know, and this is what I told you 20 minutes or so ago, is which calculator to use. So what calculator do you think we're going to use to answer this question? Yeah, sample size for mean. Okay, we want a mean because it's an average salary. It's not a proportion of something. And we want to find out how many you must survey. That's the sample size. And for that, all you have to do is put in sigma. Sigma, I told you, was 25. That's the standard deviation. E is the margin of error. And the margin of error, 50 cents or 0.5. And we want a confidence level of 95%. And that's 0.95. And we calculate N. Okay. And notice, is this a big sample size or a small sample size? Yeah, this is big. Okay. If you really had to do this, you've like grown. Okay, I'd be groaning. My guess is you'd be groaning also. Do you all agree? So the choices are we can change the confidence level. And let's say we change it from 0.95. Let's say we're okay with only being 90% confident. Notice that's a lot fewer, right? That's 6,764. Do you see that? Any questions on that? But that still may be too many. So if that's still too many, what might you do? Any thoughts? In the real world, if you were concerned, you wanted to find out about the average age of nurses' salaries. You could go lower. In our class, we're never going to go lower than 90%. And you almost never see lower than 90%. What else can we do? Remember, you're the one that wants to be a nurse. So you're interested in this. But you don't want to survey that many people. Yeah, you can increase the margin of error. You could say, well, maybe I'm okay with it being off by $2 an hour. Okay. So if we went to 2 instead of 50 cents, now it's a lot easier. Do you see that? Now it's only 423. You can have a bigger error, so you're not going to know the salary that well, but maybe $2 an hour is not too bad to be off by. Does that make sense? Any questions on that? You can't change sigma. That's not something you can change. That is the standard deviation. It's your best guess, and you can't change your guess. But you can change E, you can change confidence level. Any questions on this idea? All right, let's do one more. And now it's for sample size for a population proportion. Okay. I'm not going to go into the math like I did up here, kind of showing where it comes from. The main reason is the math is a bit uglier, and I don't want to have all you guys all log off because it's too scary. But you can trust me that I did the math right. Sound good? All right. Now let's suppose that you want to find a 99% confidence interval for the population proportion of cars in the United States that are electric EVs, electric vehicle. Okay. Let's suppose you want a margin of error of no more than 3%. How many cars must you look at? And by the way, notice in part A, you have no idea what percent are EV. Okay. So if you have no idea, then that's going to be important. So first thing, can we use this calculator? Sample size calculator. Yeah, absolutely not. Okay, this is for a mean. It's got a sigma. Proportions don't have sigmas. Okay, there is no standard deviation for the yes/no question. So we need to go back to the calculator menu and hope that there's another one that I made. And by the way, if I say hope, it's going to happen. Okay, which one do you think we're going to do? Yeah, number 13, sample size for proportion. Because now it's either it's an EV or isn't an EV. It's not a amount of EV a car is. There's no, it's a yes, no for this car. Okay, so notice for this one, there's a have an estimate and don't have an estimate. In this example, we do not have an estimate. We have no idea what the population proportion is. Okay, that's how this example is. So we just want to write down what is the margin of error. We want a margin of error of no more than 3%. Something you do have to know how to do is you have to know how to turn 3% into a decimal. What is it? Yeah, 0.03. Always move the decimal over 2 places to turn it into a percent to a decimal. Confidence level. We want a 99% confidence. So 0.99. Any questions on that? And I calculate n. And what do I get? 1,844. Any questions on finding the sample size you need to be able to have a confidence interval that has a margin of error that is small enough with a certain confidence level? So in this case, we need to look at 1,844 cars. Any questions on that? Okay, so now there's some different things you can do. You could change the margin of error. You could change the confidence level, but here's another thing you can do. You could actually do a little research and maybe get an estimate. Maybe look up last year and make that your best estimate. So this is part B. Let's suppose that last year we looked at the data, and I did, by the way, 2.2% of all cars were EV in the United States. Now, how many cars would you need to look at for the 95% confidence interval? What changes? What changes this time? Not E. No, still margin of error is 0.03. Yeah, now we have an estimate for P. And if I click on that, you'll notice now there's a new bar, a new box. And it asks you, what is that estimate? Do you see that? What is our estimate? What's the estimate for P now? Yeah, I'm not sure. Yeah, 0.022. Yeah, I saw it 0.023 because you need to move the decimal over 2 places. That puts a 0 in front of that too. 0.022. Any questions on that? Now, if we calculate n, it totally changed. Do you see that? Now we only have to look at 159 cars, and that is much easier. Any questions on that idea? So having an estimate turns out to make a big difference if it's either a very small percent or a very large percent. It turns out if the percent is close to 50%, doesn't change it much at all. But if your estimate is actually high or small or low or high as a percent, it actually makes a big difference. If your estimate's 50%, it makes 0 difference, it turns out. Because it turns out that you can just trust me when you do the math. It turns out that if you don't have an estimate, you use 50%. And there's some math reasons I'm not going to get into, but there's calculus involved. So not doing it. Okay, but you can trust me. Any questions on getting an estimate for n? And by the way, if you don't have an estimate for n, you can't conduct a survey. If you don't have an n, you can't conduct a survey. If you have no idea how many people you have to ask, then how many do you ask? I don't know. So this is actually really important when you're doing your planning of a survey. Any questions on that idea? Any questions? So things you have to decide on is one, is you have to decide, is it a mean, like hourly wages? Or is it a proportion, like, is it an EV? Okay, if you decide wrong, you're going to get the wrong answer. So you have to think about what data are you collecting? In this case, it's the data is EV or not EV, yes or no. In the other case, you're collecting a wage, and maybe it's, $70 an hour, and that's a 70, a number. Do you see that? So that's one of the hard parts about being able to answer these kind of questions, is to decide, is this a mean or a proportion? So is it a quantitative or a yes, no question? The other one is to know that you're asked for a sample size. The how many must you survey? That's how we know it's a sample size. Okay. Any questions on that? So how many cars must you look at? That's a sample size. It's not a find a confidence interval. And it's because if you try to click on find a confidence interval, you're not going to be able to answer these questions. Any questions at all on any of the examples that we did today? All right. The good news is the secret word. Secret word is many. And I put it that way because if we look at the template, if we look at some of these, if many samples are taken, so that word many happens in this template for the confidence level. So I decided that's a good word to use for a secret word. I always try and pick a word that's used a lot. Okay. We're a little earlier than before, but it averages around an hour and a half. And the last few times, if you've been looking at your clock, it's been like an hour and 45 minutes. So now we're an hour and 15 minutes, a bit easier. There's also an exam coming up, so I sometimes shorten it a bit. But always happy to answer questions. And I think I am going to stop the recording because pretty much we've covered what we needed to. This isn't necessarily the hardest of the weeks. Maybe you'll like that. But it's an important one. So hopefully it went well. So I'm going to stop the recording.